for our first example, it says with the given information provided. All right. So when it says, first of all, make a sketch, what you want to think about is you're not actually getting a protractor out or a ruler and measuring things per se. A sketch is just a drawing,
rough sketch.
Okay. Now the key is we want the information in our sketch to represent kind of what we're having. It may not be drawn to scale, no big deal. All right. It does say label all the angles that can be determined as well. So we'll I'm going to start that, kind of talk about what that means.
Okay.
So it says we're going to draw a sketch of some vertical angles. So think about what that looks like,
okay,
where they each measure 52 degrees. Now, how would I draw vertical angles?
Well, vertical angles happen when we have two lines that intersect. So I probably want to, in my sketch, draw two lines that intersect.
So there's one, there's two.
And we've got a nice straight edge that we can use. You don't have to use a straight edge. It
Yes.
can be just freehanding it. That's fine too.
All right, so we draw, and so in this picture, you should see some vertical angles. What else do you see in this picture?
Well, we know there's also going to be linear pairs as well.
So I'm going to make a little note. We do have vertical angles, but we also have some linear pairs. So keep that in mind when we start labeling some things. Anytime you see a pair of intersecting lines, you should be thinking vertical angles and linear pairs every single time.
Okay.
All right, so we know these vertical angles measure 52 degrees. So let's say I label this angle 52 degrees, which automatically means I could label
Its vertical angle is also 52 degrees.
So the vertical angle would be right across from it, right?
Exactly.
So this would be 52 because we know by vertical angle theorem, vertical angles are congruent, so that means they are going to have the same measure.
Okay.
So did I label everything?
Well, no, because we had said to label all angles, and there are some angles there that are linear pairs with those vertical angles that are not marked yet.
So we could find a linear pair to the vertical angle of the 52 degrees, and that would be, what,
128, yes.
All right. Now, I know that that means also this angle is also 128. Why?
Well, I could say because it's a vertical angle with the other 128, or because it's also a linear pair with a 52. So there's a lot of ways I could think about that.
So when it says label all the angles that can be determined, that means we want to find anything that's possible based on just this one little piece. And since we know one of the vertical angles, we technically know all the others. And we kind of did some of this in chapter 1.
All right. This next one says complete the statements given that, and I'm going to go ahead and mark the things that we are given.
All right, that sounds good.
Okay, so we are given that the measure of angle EHC, so this right here, EHC, is the same measure as DHB. So here's DHB. I'm going to mark that one also. So those two are the same measures. And it's also equal to the measure of AHB, and they're all equal to what?
90 degrees.
90. So if you want to leave it like this, you can and just put some 90s. Or if you wanted to, you could put your little right angles marks because we know that they're 90s. So I'll let you guys make that decision. I've learned in this problem that it's probably easier to mark them just with the little right angles, but if I were you, I would kind of make those little boxes a little bit bigger to say this one, and
it's not that one.
It's not. I knew I was going to do it.
EHC. So that one right there. Perfect.
That one. And now DHB. Here's this one. And AHB. There we go. So to mark them with those right angles. Now, you can mark them really close. You can mark them far apart. But be careful because they have some overlapping parts. So that's the tricky thing.
And bottom line, it's the labeling is so helpful. And if you don't label your picture, you might be missing out on that information, which means you might get stuck on the problem. So label, label, label.
Exactly. Now, on this one, we've got 3 different questions. And notice that they're in conditional statement format. But one is not going to imply the other one on this question. So just be careful of that. So we're going to do everything for number 1, and then we're going to stop and we're going to just kind of make sure that we're looking at it separately for number 2.
Okay.
Okay, so for number 1, they say if the measure of angle 7 is 28 degrees. So if I mark this as 28 degrees, then we want to know something about the measure of angle 3. Well, looking at those, what do you notice, Mrs. Palermo?
Well, I'm noticing angle 7 and angle 3 are actually vertical angles.
Yeah, and if it helps to kind of just draw those lines, emphasize those lines to see that, you're welcome to do that.
So if they're vertical angles, we know by vertical angle theorem they're congruent, which means angle 3 is going to have the same measure, which is going to be 28.
Okay, now, there's also another step to this. It says support your answers with either work or an explanation.
And there's not any work really on this one.
So what would your explanation be?
I would just say vertical angle theorem.
Vertical angle theorem.
So
perfect. That. And I can't say definition of vertical angles. It's not the definition. It's that vertical angle theorem that says that they're congruent. So therefore, we know their measures are equal. Perfect. Now, for this next one, you know, I always have students that want to say, oh, I'm supposed to find the measure of angle 7. We already know it. It's 28. It's a whole different question. So I'm going to go up here and I'm just going to erase this marking because I don't want you to think that that depends on, or that's part of this new problem. Now, for this one, they say the measure of angle EHB. So let's go and take a look at EHB. So all of this is 121. We're supposed to find the measure of angle 7.
Okay. Well, that's 121. And I know I'm probably going to have to use some of like those 90 degrees, don't you think?
I think that'd be a great idea.
Okay. And I also know, like kind of going off of even the first one, I know angle 3 and angle 7 are congruent. So I might just...
So we kind of might want this angle 3 first.
Maybe. All right. And if I know that whole, like, and the reason why I'm thinking angle 3, because angle EHB has angle 3 part of it.
Exactly.
And I know that angle 3 plus the measure of angle EHC makes up angle EHB.
Okay.
Which is the 121.
So altogether, the 3 and the 4 and 5 together are 121. And what do you know about the 4 and 5 together?
The 4 and the 5 together is the 90 degrees.
Exactly.
So if I could take 90 degrees from, subtract that from 121.
Okay, because this, again, was all of 3, 4, and 5 together, right?
Yes.
And this 90 is talking about 4 and 5 together. So if I take away the 4 and the 5, that makes sense. It would leave us with 3.
Yes.
So what did you find out when you took 121 minus 90?
It's going to be 31. Now that's the measure of angle 3, right?
That's the measure of angle 3.
And I wanted angle 7, but I already said angle 3 and angle 7 are congruent.
Yes.
Because of vertical angle theorem.
So is that another thing you think I probably should state in my work or explanation? I think that's great. So we know that 121 minus the 90 would give us the measure of angle 3 is 31. And the measure of angle 3 is equal to the measure of angle 7. Or you could just state that the measure of angle 7 is equal to 31 because of the vertical angle theorem.
Okay.
This isn't a formal proof, so we're not looking for every little piece specifically to, you know, the details of they equal each other, this is then equal to the 31. But we do want to know that you've shown your work, that you've shown how you've gotten to the 31 degrees, and knowing that vertical angle theorem is important there too. Okay, now, this last step does not depend on this 121 degrees, so I'm going to take that off, and I'm going to get rid of these question marks that we had here. And now, this one says that the measure of angle 3 is now going to be 34.
Okay.
And we're trying to find the measure of angle 5. Get rid of the other little marks that I made too. Okay, so going back to what we started with. We know we've got some right angles here, right?
Mm-hmm.
In fact, how many sets of right angles do we have?
We have 2 sets of right angles. Well, 3 altogether, but 2
that are involved
you just kind of were talking about.
Okay, and one of them's 34. We need to find 5.
Okay, so I'm thinking a couple different things.
Okay.
I'm thinking of a shortcut first, just because I'm like, I like to go quick. I know that I noticed that angles 3 and 4 make up the 90 degrees, so that means angle 3 and angle 4 are complementary. And 4 and 5 also add up to 90, and so that means they're complementary. So since angles 3 and 4 are complementary and 4 and 5 are complementary, so 3 and 4 complementary, angles 4 and 5 are complementary. I'm seeing angle 3 and angle 5 are going to be complementary of the same angle. That means angle 3 and angle 5 are congruent.
Yeah, and what theorem did we learn that told us that?
The congruence complement theorem.
Yeah, when two angles were complementary to the exact same angle, they're congruent to each other. That is that congruent complements theorem.
So
and if you catch that,
great.
Awesome. That you can get there otherwise, though, too, right?
Let's talk about the other way. So that means angle 5 is 34. So another way you could do it is you could find, okay, if you know angle 3 is 34, then you can find angle 4. So you could find that by doing like 90 minus 34.
Right.
And that gives you what? 56?
Okay.
All right, so that's angle 5. And then I could find angle 5 by doing 90 minus 56 because 4 and 5 make up 90.
Exactly.
And then that gets you back to the 34.
So you could get there other ways, but that congruent complements theorem, if you see them, is another thing you can use on this one.
So you can support it with either work, kind of what she did in red, or if you see a shortcut using a theorem, you can do that as well.
Awesome.
Now, let's try, so we started today with some more kind of sketching and finding missing angles. Now let's do some proofs to go with. And again, think about like some of the theorems or postulates that we talked about a little bit earlier today as well as last night. So don't forget about that stuff too.
Okay.
So we're given here some angles that are equal. So angle 8 is equal to angle 5. I'm going to go ahead and label that in the picture. And hopefully you're doing that along with me. And then angle 5 is equal to 125. And again, when you show an equal or congruence, you can just show the tick marks there. I know this is 125, so I'll go ahead and label that. That's given.
All right. Now, right there, I can see that probably angle 8 is going to be 125 degrees too.
Okay.
We haven't made a statement with that yet. We could, but we haven't made a statement with just stating that yet.
All right. And hopefully that's an obvious.
Yes.
So then notice where we're trying to go. We're trying to show angle 7 is 55 degrees.
Okay.
Now, just something to keep in mind is think about, okay, you know, what do we know? What other things do we know about angle 7? Because that's where we're going. Notice the given does not say anything about angle 7.
It doesn't.
So you might have to think about is there something unique about angle 7? And think about, you know, these angle pair relationships that we've been talking about.
Okay. Well, like 7 and 8 are a linear pair. And that's one that we said you can look at the picture and be able to make that statement.
So we can maybe say something from that as well, okay?
So, okay.
All right, let's think about it. I want to go back to what Ms. Hokerby said. She said something about, well, she knows that right away angle 8 is going to be 125. Can we say that from based on our what's given to us?
Yeah, because they're all equations, so I can substitute that 125 in place of the measure of angle 5 and now state that the measure of angle 8 is equal to 125.
And I, like you said, substitution. And you could use transitive here again. I'm just going to write, and guys, we're going to get to a point where we may not write both reasons, but we'll state them so you're comfortable with that. All right, so we've used really both parts of the given, if you think about it. I'm going to go ahead and label this is 125. So really, does angle 5 or angle 6 have anything to do with angle 7 at this point?
Not at all.
No, so we're just looking over here now.
Okay, and just by looking at it again, these should not be a far stretch when you take a look at this, because I can tell right now that 7 has to be 55 because I know that they're a linear pair. So I'm going to think back for a minute because we said the linear pair postulate tells us that they are supplementary.
Okay.
So I'm going to make a statement and say that angle 7 and angle 8 are supplementary. And that reason is because of the linear pair postulates.
Now, I couldn't just say angle 7 and angle 8 add up to 180.
Well, no, because the theorem actually states that they are supplementary.
All right.
Now, that's a statement I will want to make next, though.
Yes. And again, going to that fact, we can't just go ahead and say angle 7 is 55 because of the linear pair postulate. The linear pair postulate says angles are supplementary based on the fact that they're a linear pair. All right.
Exactly. And the hardest part about a proof, it's not being able to prove these things. It is really thinking of the logical argument.
Yes.
That takes you step by step to be able to show that.
It's kind of like the showing the work. Some of us don't like to show that work. With proofs, you got to show all those little details.
Okay.
All right. So again, we've used the given. We haven't used this. We've just proved that, and we've stated this from the picture. Again, pictures very useful in this case.
Okay. So now I know that I've got an equality statement in step 2. So I'm going to turn step 3 into an equality statement also and say that the measure of angle 7 plus the measure of angle 8 will equal 180. Because that I know is the definition of supplementary. That's when I say making that statement, I can always say their measures add to equal 180.
And that's a pretty common flow. If you know angles are supplementary, a lot of times you're going to say that they add up to 180 or vice versa. If I say that angles are supplementary or that angles add up to 180, sometimes you'll just go straight here. And again, notice how Mrs. Hogarby said since this had equality and this did not have equality, we need to state equality. All right.
Exactly. Okay, now I can do some substitution because I have 2 equality statements, 2 equations. So I'm going to go ahead and put that 125 in place of the measure of angle 8. So I'm going to say the measure of angle 7 plus 125 is equal to 180. And that would just be substitution. And here's one where I can't use congruent, or I can't use transitive, because I'm not saying they're equal to the same thing, so they're equal to each other. I'm just taking and putting it in that one spot.
All right, that makes sense. That doesn't happen a lot.
No, it doesn't. A lot of times they're pretty interchangeable. Okay, step 6. Now, I'm looking at this, and I just need to be able to say that the measure of angle 7 equals 55, and I could do that if I took that 125 away from both sides. So let's use some ESPO.
All right.
And say the measure of angle 7 is equal to 55.
And my reason?
Is ESPO, subtraction property of equality.
And we just subtracted 125 on both sides. We got an answer. And again, guys, this is definitely a great example of how it's kind of a no-brainer that we know angle 7 is going to be 55, but we needed to have the support of it. No gaps in our proof, and we are finished with that.
And you know, Mrs. Palermo, I always have students say, why do we do proofs? Because, you know, it's kind of no-brainers. They're telling you exactly what you're supposed to get. The whole point of proofs, you guys, is so that way you're used to being able to support with a logical argument, support your answers with a logical argument. This is one of the best things about math, is you're going to use this skill so many times in your everyday life. And being able to have that support and being able to truly support your answer, not just saying, because I said so.
Yeah.
There is no because I said so proof. You're going to need to be really comfortable with this natural argument.
You want to be able to convince people of what you're thinking.
Exactly.
So that's what this is a good skill to have.
All right. This next proof that we have, notice that we have a set of angles are congruent and we're proving another set of angles congruent.
Okay.
Okay, so let's go ahead and let's label what we've got. We know that angle 1 is congruent to angle 3. And if I mark that in my picture, I'm just going to put my little tick marks to say angle 1 and angle 3 are congruent. We want to prove that angle 2 and angle 4 are congruent.
I see what you're talking about. Now, one thing, I'm seeing something in the picture, but I look at the given when you wrote that down, and saying angle 1 and angle 3 are congruent really doesn't elaborate on anything else. All I could really say is probably angle 1 and angle 3, their measures are equal, but what's the point of that if I'm dealing with congruence? I probably don't need to switch that over. So this is definitely one where the picture is huge.
Yes.
So we look at that picture, and I'm hoping everybody's seeing this with me too. I'm seeing in this picture I have some vertical angles.
Absolutely. And always look for those pictures, those vertical angles and those linear pairs now.
Now, obviously there's linear pairs, but I noticed that there's not any labeling of those angles. So that's kind of a helpful hint that we're not going to use those.
Exactly.
You don't want to add numbers to the picture just to make your proof work out. You're going to use the names that they give us. All right. So I'm thinking I can say, I don't have to say that they're vertical angles because the picture, we know that. So we can just say what we know about them, and we know they're going to be congruent. So angle 1 is congruent to angle 2. And that's because of the vertical angle theorem.
Okay. But we also know...
Well, there's another pair of vertical angles, right?
Right.
So I could say angle 3 is congruent to angle 4.
Can I do it in the same step, or do I need a separate step here?
Okay, well, let me think about when we can put them together is if they have the same reason, which they do, and they don't depend on each other. So I could have said angle 3 is congruent to angle 4 first, so I can put it in the same step.
Exactly.
Now, can you separate them out? Well, of course.
Sure.
Yeah.
Absolutely. Okay, so now we haven't used our given yet. We've based this step 2 off of the picture. So now let's go back to our given.
Okay, so here's what I'm thinking. I can just go ahead and say angle 2 is congruent to angle 4, right?
Why do you think that?
Well, transitive.
Okay, because you're seeing the 1 in the original statement, and you're seeing the 3 in the original statement.
So, yeah.
But transitive would only work if you have 2 statements that are congruent to the same thing, then they're congruent to each other.
Okay.
Really, that would work. That idea would work if this was all equations and I could use some substitution, because you can substitute multiple things in.
Yeah.
But transitive does not work that way. And that is a common mistake that students will make. So be careful with that.
All right. So here's what I'm thinking. So you're saying we need to use 2 congruent statements to come up with a third. So I can maybe use the given.
Okay.
And then the angle 1 is congruent to angle 2. And because they're both congruent to angle 1, we can say angle 2 is congruent to angle 3. And that would be because of transitive.
Awesome. Now, if you take a look at this, we've got another new statement. We haven't used it. And we haven't used this other statement in our vertical angle theorem.
So we have 2 true congruent statements, and notice they both have angle 3 involved. So that means angle 2 is congruent to angle 4.
Now, can I put that in the same step? Because that's still transitive, right?
No, because here's what you said. You said you only can do that if they don't depend on each other. And what they mean by that is, could I put that before that? No. Angle 2 and angle 4 being congruent depends on angle 2 being congruent to angle 3.
Right, because we're using this.
Using that to come
help
up
us
with
make
this.
our new statement.
So I need a whole new statement.
So we're going to state that angle 2 is congruent to angle 4 because...
transitive again.
Exactly. And I love the way you described that. When I am looking at 2 congruent statements that I need to be able to make a new congruent statement, if one of the ones that I'm using, even if I've just used the transitive as a reason, if I'm reusing this statement to be able, or using that statement to make a new statement, I cannot put this statement as the same step.
Yeah.
It's a whole different step.
Okay. All right. Another example. It says ray RV bisects angle RST.
SRT.
Yes, SRT. Sorry. Bisects, I'm going to underline that word because that's probably an important word for us to understand. We'll elaborate on that in just a minute. Angle 3 is congruent to angle 1, so I'm going to go ahead and label that. And I'm going to start writing down the given. And again, notice where we're going. Always keep that in mind. But I'm going to ask you, Ms. Hochgraby, what does bisects mean?
Okay. So I'm thinking back, this is chapter 1 when we talked about bisecting an angle. And I remember we even did some constructions with this. But we were talking about when an angle is being bisected, it's a ray that will divide that segment into 2 congruent angles.
So if this ray RV bisects angle SRT, that means
that angle 1 and angle 2 are congruent.
And notice how she named those angles. Yeah, you could name it angle SRV and angle VRT, but since there's numbers given,
that's way easier.
And that's probably where we're going, because notice the other stuff in the given and deal with the numbers, and the proof even deals with angles being named by number. So I'm going to say angle 1 is congruent to angle 2, and what's the reason?
That's the definition of an angle bisector. Can I just say definition of bisects?
What do you think?
Well, I guess it's not very clear when I say bisects. So I need to know
think about angle bisector, because you're dealing with bisecting an angle.
Okay, sounds good.
So we already know angle 1 is congruent to angle 3. Now we know angle 1 is congruent to angle 2. So I can just use the same amount of tick marks.
Oh, well then this is way easy. Because we already know that 1 was congruent to 3, and now 1 is congruent to 2. So I'm going to put those two statements together because both 2 and 3 are congruent to angle 1. They're going to be congruent to each other. And I look at how they're going to ask me to write my answer with the prove. They're wanting me to put 3 first. So I'm going to write it as angle 3 is congruent to angle 2. And that's the transitive property.
And can you use substitution?
I can't because it's congruence, and that is not a property of congruence.
Good deal.
Only
Again,
transitive.
a short proof. This one didn't deal with any like linear pairs, vertical angles. Notice the picture that's not dealing with that. Supplementary, complementary, no right angles. This is just kind of a more practice from chapter 1 a little bit with that keyword of bisects.
Our last proof that we have up here, we are told that angle ABC is a right angle, and we are told that angle DBE is a right angle. And I'm just going to mark those with the little kind of boxes in the corners to keep track of what that's going to look like. All right, Mrs. Palermo, what are some things that you're noticing while I'm writing this down?
Well, I immediately took a look at the prove, and I see that the prove part said we're going to prove angle 1 and angle 3 are congruent. And I noticed the given doesn't say anything about angle 1 and angle 3. I do notice in the picture there's something, I do see the angle 1 and angle 3. But I know I'm going to probably have to say something about that. So I'm going to keep that in the back of my mind. What I like to do a lot of times is I like to kind of feed off the given if I can.
Work it backwards.
So I know angle 1 or angle ABC and angle DBE are right angles. So I could say that they're congruent. I could say they equal 90.
What do you want to go with here?
I'm thinking, this is what I'm thinking. I'm thinking I'm going to go ahead and, since I know I have to say something about angle 1 and angle 3, I'm going to go ahead and go to the picture and say something about them. Just because I know I got to say something about them, and then maybe that will help me kind of think. There's lots of things that I'm thinking. There's a lot of things I could go with. And sometimes, guys, you start writing your proof, and then you change your mind. And then you're like, oh, I need this in here. So just keep that in mind. You might
And it's okay to have extra steps, but it's nice to not have to have extra steps. So I love that you're kind of looking at where you're going, and you realize I'm going to need to talk about these angles and kind of work it backwards a little bit. So then what do I already know about them?
So I'm going to have to say, all right, and it has to relate somehow to the angles that were given. So I know that angles 1 and angle 2, they add up to angle ABC.
Okay. So let's...
The measures.
Yeah. Right. So measure of angle 1 plus the measure of angle 2 will equal, and I love that you said the measure of angle ABC, because we do know something about angle ABC, but what did you just use to be able to write that statement?
That was the angle addition postulate.
Exactly. And the angle addition postulate does not have any numbers in it.
Yes.
The angle addition postulate is strictly just the names of those angles, the measures of each of those, but you're using the names, not putting numbers in.
Exactly. And I'm going to do in the same step, because I know I have to say something about angle 3 and relate that to the other. So angle 2 plus the angle measure of angle 3 is equal to the measure of angle DBE.
Okay. I think that's perfect.
Okay.
Good start. Now, with what we've got, how is the right angle stuff going to help us with this?
Okay. So I'm thinking couple different things, and I'm just going to go and we might see, and we might come back and talk about another option. I'm thinking we could say the measure of angle ABC is 90, and the measure of angle DBE is 90 as well in the same step, because they can be interchangeable. And the reason why is because the definition of right angles.
Okay. Love it. So now I know some more information about them. I've used this given step. I'm going to take a look at those equations that we've written again, but now we know that those two larger pieces equal 90.
And there's other things you could say here. I'm thinking,
there are definitely several ways to do this proof.
I'm thinking all sorts of things. I'm just like, okay, I'm just going to start just having you write it down. Okay. So at this point, and I can think of other things to do at this point, I'm going to go ahead and I'm going to replace the 90 in for angle ABC as well as 90 in for DBE.
Okay. So using a little what?
Substitution.
Love it. Measure of angle 1 plus the measure of angle 2 is now equal to 90, and the measure of angle 2 plus the measure of angle 3 is equal to 90, all because of substitution. Okay?
Okay. All right, so...
And by the way, could we have used transitive there?
Yes.
Okay.
Oh, no. Could we have used subtransitive? You're just replacing... Yeah, no, you can't. You put 90 in for... Oh, I guess, yeah, we could use
transitive. Because they both equal ABC, so they equal each other. That would work.
Substitution, I think, to me, is more of a logical
when you're working
thing.
with numbers, that's what I always think, too.
Mm-hmm. All right. So, at this point, so I'm thinking a couple different things. I'm trying to be more, what would you guys think? So, I'm thinking maybe go ahead and set angle 1 plus angle 2 is equal to the measure of angle 3 plus, or angle 2 plus angle 3 because they both equal 90.
Sounds like a logical plan, right? Because we know they both equal the same thing, so they equal each other. Measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And what reason would you use there?
You could use substitution, and you could actually use transitive.
Really on either one of those steps.
Mm-hmm. Now this one, I'm seeing it now. I'm seeing it. Sometimes it takes a while to see it. So I'm gonna then subtract angle 2's measure on both sides.
Okay.
Because they're on the same on both sides. So angle 1's measure is equal to the measure of angle 3 because of ESPO. And then I can say they're congruent because of the definition of congruence, which is where I wanted to go.
Perfect. Now, you mentioned that there's some other ways that we could have gotten there.
Yes.
And I'm just going to go back to, let's go back to this step.
Mm-hmm.
We know we're going to need an angle addition postulate in there. Mm-hmm. That's given because we need to somehow talk about angle 1 and angle 2 being together forming that ABC since they're giving us ABC in the original step. Mm-hmm. So you have to have this step in there.
Yes.
But when we have two right angles, we could have said that angle ABC was congruent to angle DBE. So that's another way that I could have gotten there. Talked about how these two angles are then congruent. But then we would have to be able to get them to an equality state to be able to then use that angle addition postulate with them, which would have gotten us right to this step here also. Once I knew that they were equal to the same thing, they're equal to each other. So I would have put those two together and I would have ended up the same way. So there are other ways you could have done this proof, and it's not saying that one is better than the other. It's just a matter of there are different ways to go about thinking about them.
The other thing I was thinking, this is after step 4, if we did decide to, if we did it like this and said those angles add up to 90, you could also think, well, what's true about angles that add up to 90? What kind of angles are those? Those are complementary. And so you could have said angle 1 and angle 2 are complementary, angle 2 and angle 3 are complementary, which when you have two sets of complementary angles that are complementary to the same angle, we could jump right in and say they're congruent. So that
congruent complements.
That would have maybe taken off an extra step, but still not super quick. So sometimes when you use a theorem, sometimes it makes it quicker, really quicker. Sometimes it really doesn't make a difference, so you could do it a different approach.